Hi, welcome to another episode of DE 24/7 podcast. I'm Senior Editor Kenneth Wong. This month, the Industry IoT Consortium and International Society of Automation co-published the IoT Security Maturity Model 62443 mapping. This is aimed at asset owners, product suppliers, and service providers. So, to get a better understanding of it, and how it's relevant to digital twins, we are speaking with Frederick Hirsch, an independent consultant who co-authored the maturity model. Frederick, would you mind introducing yourself and explaining to us what the security maturity model is?
Yes, hello. Thank you, Kenneth. I'm Frederick Hirsch. I'm an independent consultant, and I've one of the co-authors of the Industry IoT Consortium's IoT Security Maturity Model, which I'll refer to as the SMM, and also I'm a co-chair of their Trustworthiness Task Group. The Security Maturity Model is a maturity model that we created since we needed to cover both IT and OT, and discovered there's a number of maturity models, but they didn't cover everything. Some were IT, some were OT. And so we wanted something that would drive a conversation among stakeholders that could let them solve their problems in a consistent way. It's different in the sense that when we talk about maturity, we don't mean using higher security levels. We mean that you're mature in the sense that you use what you need to use to solve your problem for the risk you're concerned about. So if, for example, you have data that doesn't need to be protected, there's no reason to encrypt it. And even though you're not using encryption, you're still at a high maturity level. So maturity to us means a good fit between what you're trying to do and how you're doing it. We also want to make sure that we understand the context of what we're talking about. So even in a manufacturing environment, you need to know the extent to which you wish to enforce security. You might not include the cloud, for example, if that's provided by somebody else. So you have to define the boundaries of what you're working on.
What's the potential security threats to digital twins that people have been launching and maintaining, Frederick? How does a security breach in the digital twin, the digital asset, affect the real world equipment like a tractor in the field or farm equipment?
So why don't we start by reminding people what a digital twin is? It's a virtual representation of something real, an asset or perhaps a process. Now, in the security maturity model, we have the concept of comprehensiveness levels. So we talk about you can start at level 1, 2, 3, and 4, where at level 1, you're doing things kind of randomly. Level 3, you're using standards and are much more consistent. And at level 4, you're formalized and using considering the entire life cycle and so on. What we have is we have 18 practices in the security maturity model, ranging from governance to controls like identity management to things related to operations and situation awareness, that sort of thing. So there's 18 different things, all of which have comprehensiveness levels. Then what we've done is we've created a digital twin profile that adds additional guidance for all those things for digital twin. So to get to your question, there, what's special at a level 1 where you're not really doing much that's special? In our profile for digital twin, we say we treat the things separately, so we don't really think about the threats together, or the you can have your normal attacks on a digital twin system and cause problems with it, and likewise for an asset. What gets interesting though is when you consider the two together at a level 2, for example, where the impact on one impacts the other, which is what you're talking about. So two scenarios for digital twins are predictive maintenance. That's one. And another one is where you use it to do testing that you normally wouldn't be able to do or wouldn't want to do because of the cost in the real world. So for example, with predictive maintenance, you might have an aircraft engine and you have a model of that aircraft engine, and you actually gather data from the engine in operation and predict how it's doing, and use your model to figure out if there's a problem. Well, if I attack the model, that can affect your predictive maintenance, whether I attack the data or the artificial intelligence or the analytics. And that could cause you not to do the maintenance you need to do, which could cause an engine failure, which could actually be catastrophic in flight. So I think it's important to protect your digital twin so that you don't affect the real world asset, namely the engine, even if it's only predictive maintenance. Another scenario is the one of testing. Now, if you have vehicles, autonomous vehicles, or other things, I'm there's all kinds of cases where you can't do all the testing in the real world. Either you don't have the time and resources to do every conceivable real test that you would drive to do, or there's some tests that would be simply too dangerous and you wouldn't want to do them, but it would be nice to know what would happen. I think this is even more applicable in aircraft. And again, if you attack the digital twin, for example, then your testing might not be appropriate, and you might actually not have done a test you thought you did, or the test result might have been changed from what it was to something else, and that again could have long-term results on the safety or operation. At level three, we talk about, in terms of comprehensiveness in the model, we talk about how you might attack both the twin and the asset, and that requires a bit more thought. It would require changing perhaps sensor values as well as the model or how the twin processes them. I don't have an immediate example I can think of. If you're This isn't really a digital twin, but if you have, for example, an insulin pump that uses a model to deliver insulin to somebody based on glucose readings from the bloodstream, if you affected the glucose readings, then the model would do the wrong thing. And if you affected the model as well, so it got rid of the limits, then you could have those two attacks together cause a person to die from inappropriate insulin injection.
It's one thing to have the digital twins security compromised due to either the failure to follow the proper procedures or uh, implementing encryptions and things like that. But it's quite another to anticipate an intentional attack on either the physical asset or the digital twin that controls a physical asset. Is that a concern in certain industries more than others? For example, is it a bigger concern for automotive and aerospace than healthcare?
It's more along the lines of, as a practitioner in your field and in your industry with your system, you need to use the security maturity model to go through all these different practices and evaluate where you need to be as a target for comprehensiveness. For example, your digital twin might use third-party software. That could be a route of problems for your system if that third-party software is compromised. Yet if you only think in terms of other things like the communications software, security, using TLS or what have you, you might not even think about the third-party software, which is why I would recommend using the security maturity model so that you cover all the bases.
In general, I'd like to understand how the responsibility is distributed among the different parties that some of them you have actually mentioned. So is it the equipment operator or the equipment manufacturer or the control software's developers' responsibility to implement certain pieces of these?
So we've followed through on the 62443 where 4.1, that's one of their documents, shows a graphic which shows the different roles in a manufacturing environment, if you will. And it shows that you have the role of the asset owner, you have the role of the product supplier, and you have the role of service providers, whether it be for integration or for maintenance. And all of these play a role, obviously, in security, but the 62443 community has developed requirements that are applicable sometimes to some of them and sometimes to all of them. So you'd need to consider all the roles. And if you're the asset owner, for example, if that's who you are, then you would turn to the SMM to see where your concerns are in terms of comprehensiveness. And then you would turn to the mappings to see which 62443 requirements from those 62443 standards apply to you directly, and make sure you have met the requirements that correspond to the comprehensiveness level that you care about. You would also want to be aware of what the product supplier is doing, and hopefully you'd be communicating with them as well. They have their own set of requirements to achieve comprehensiveness levels, and they too should be making their system secure, as should the service providers. Obviously, in any system, the system itself is open to attack, and the attacker really doesn't care who's doing what role and what's going, they're just looking for a way to an attack, right?
The last thing, Frederick, I'm hoping you could help us understand is what it means to implement security maturity measures or security measures in general. Does it mean to put in practice certain encryption to protect the data, or to put some sort of data checkout policy, check-in policy, or doing something physical, putting some sort of gadgets into the physical asset itself. So what does it involve?
Well, it's really all of that, and that's again why you need the security maturity model to figure out what your targets are and what matters to you, so you don't try to do everything. You can't boil the ocean. So, for example, with physical security, you may need to have tamper-proof housings for your cameras, which may be used to monitor safety as well as security. But that depends again on your environment, whether you need that housing. You may need to use encryption or identity management techniques, but you also may need to, before you worry about encrypting, may need to organize yourself into understanding what data you have and which data is critical and which data is not critical. So you might need to understand your data before you even worry about encryption, and that's one of the comprehensiveness levels for data policy and data implementation. You have to decide how much of a identity management system you need, and whether it's spanning organizations, and whether it's consistent across devices and people. And these are all decisions. So all of the security is mostly about the decisions of as to what's important, what needs to be done. And then yes, there's all these technologies that can be used, but many things are done administratively, whether it's induction procedures for employees to make sure they have the right training and the governance, and whether you have policies in place. So it's not just about using technological techniques, it's about the combination of governance and service level agreements and understanding your supply chain risks and understanding third-party software concerns, like I mentioned before, as well as using technologies for access control and identity management and data protection and so on. And also, we mustn't forget that you need to monitor systems, you need to be able to install patches, you need to be aware of the situation and have the maturity as appropriate to interact with others, so you know what's going on. So there's a large number of things to consider, which is why I think you need to get organized about it.
My instinct tells me that a major automotive maker who is, let's say, currently developing a self-driving car with IoT features is probably at a much higher security maturity model than, say, a startup that has launched a new kind of wearable device. Is that a good way to look at it? Would it be counterintuitive in some cases where the startup may actually have a higher security maturity model?
Yeah, that's a great question. I think it talks to the point that the security maturity model doesn't just have this stepwise maturity approach that some others do. So we don't just say you're better if you're at a higher number. Again, it's about the fit. So we have these 18 practices and we call it comprehensiveness levels. So in one practice, you might have a low comprehensiveness level, but that's fine in your target because that's all that matters. And in another, you might have a high comprehensiveness level. So when you get to your question about automotive, clearly there's risks and losses that it could occur. And so therefore they have to be careful. But when they get to the details of what they actually do, some practices they might need a high maturity or a high comprehensiveness level, and others they won't. And similarly with the startup, there might be things that are absolutely critical. If they're doing something in healthcare, it might affect people's lives. So again, I think you have to look at it from with an understanding of what you're trying to do, what the potential losses are, what the hazards might be, and then look at each of the practices and set your targets appropriately.
All right, Frederick, thank you so much for helping us better understand the work of the Industry IoT Consortium and the recently published SMM 62443 mapping.
Thank you very much, Kenneth.
My pleasure. Until next time, this is Kenneth Wong for DE 24/7, and we are out.